Let us look at proposition number 11.24 of book 11 of Euclid's Elements. The proposition says, if a solid is contained by parallel planes, then the opposite planes in it are equal and parallelogrammic. So let's see what this statement means. We have two planes parallel to each other. Now let's add two more planes parallel to each other. And let's add two more planes parallel to each other. So here, if you notice, in the middle, these six planes will actually enclose a solid. And what this proposition is saying is that this solid, the opposite faces are equal and parallelogrammic. That means they are opposite faces are parallelograms and they are equal to each other. So let's mark some points so that we can refer to them. A, B, C, D, E, F, G, H. Now let me move it so that hopefully things will get clearer. So here, if you notice, we have A, B, C, D. On the other side, we have E, F, G, H. Okay, now that we have to mark these points, let's remove these planes so that things become much more clearer. So now let's color these faces. These are two opposite faces of the solid. And by the way, this particular solid is called a parallelepiped. Opposite faces again, and finally the opposite faces. The proposition is saying that AC is equal to GF and it is parallelogrammic. That means they are parallelograms. Similarly, BG and CE are equal and parallelogrammic. And similarly, AC and GF are equal and parallelogrammic. And similarly, BG is equal to AE and they are parallelograms. Okay, so now how do we prove this? Now AB is parallel to CD. Now, how do we say that they are parallel? Now planes BG and CE are parallel to each other and are cut by the plane AC. So the lines of intersection AB and DC are parallel to each other. So that is how we are able to say that AB is parallel to CD. Similarly, we can say BC is parallel to AD. Why? Because again, planes BF and AE are parallel to each other and are cut by the plane AC. So the lines of intersection are parallel to each other. So lines of intersection in this case is BC and AD. So they are parallel to each other. That means since opposite sides are parallel to each other, that means ABCD is a parallelogram. So that you have got the idea. Same way we can prove that DF is a parallelogram, BG is a parallelogram, FG is a parallelogram, BF is a parallelogram, AE is a parallelogram. Now, AB is parallel to CD and BH is parallel to CF. Now, AB and BH meet each other. DC and CF meet each other in different parallel planes. The angles are going to be equal. That means angle ABH is equal to angle DCF. Let's join AH and DF. The triangle ABH is going to be congruent to DCF. Okay. Why? Because AB is equal to DC. Because remember, they are parallelograms. BH is equal to CF. Again, BF is a parallelogram. And angle ABH is equal to angle DCF. So these two triangles are congruent. Now, if they are congruent, the diagonals AH is equal to DF. And we know that in a parallelogram, the diagonal bisects the parallelogram into two equal triangles. So, which means parallelogram BG is equal to the parallelogram CE. Similarly, we can show with respect to the other faces. So, we have shown that if a solid is contained by parallel planes, then the opposite planes in it are equal and parallelogrammic. And as I mentioned previously, this type of figure is called a parallelopiped. So that was proposition number 11.24 of book 11 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share it. That's it for now. Bye.